Welcome to Embedded. I am ELISA White. I am alongside Christopher White, and our guest this week is Kate Stewart of the Linux Foundation. We're going to talk about the Zephyr RTOS.
Hi, Kate. Welcome.
Thank you very much for inviting me. Looking forward to talking with you on this one.
Could you tell us about yourself as though we met at, an online embedded systems conference?
You probably will have seen me at some of those, yes. I've been working in software for about 30 years and open source for over 15, and have been involved with the Embedded Linux conferences for several of those years, as well as the Linux Plumbers Conference. So I tend to be focusing on the embedded side of the technology space and helping to see what's emerging and making it a little bit better. I started pretty much for the compilers way back when, and have liked to be between the software and the hardware interfaces and working with the hardware. So that's kind of my happy spot. And Zephyr is one of the projects that I'm working with at the Linux Foundation. I'm a strategic director there. And we're basically looking at how we can apply the best practices into an open source project that can be used when Linux is just too big, because Linux doesn't get much smaller than 2 meg these days. And Zephyr is, how do we make sure we have a good place for people to collaborate? And that was sort of the motions behind it. So that's the project, one of the projects I work with.
Okay, and I have lots of questions about Zephyr.
Me too.
But before we do that, we want to do lightning round, where we ask you short questions and we want short answers. And if we're behaving ourselves, we won't say why and how and are you sure? Are you ready?
Okay, go for it.
Should we bring back the dinosaurs?
No.
Compiler question. What's your favorite token in any language?
Does anyone have a favorite token?
Semicolon, actually.
All right.
Well, actually, one of the projects I work with is something called a Cregit. And what it does is it replays a Git history for a log, and instead of storing things line by line change, it stores it token by token changes. And that semicolon tends to be very useful for figuring out, where statements and logical syntax elements end. So, yes, tokens are cool.
Do you like to complete one project or start a dozen?
Start a dozen.
Do you have a favorite processor?
That one will get me in trouble.
Okay.
I need to be neutral.
What planet or moon would you visit if you could?
Earth's moon. I'd love to see the view in the other direction.
It's a short
after
trip,
all these
too.
years. Yeah, there's that. And it may even happen, within our lifetimes.
Do you have a tip everyone should know?
Tip everyone should know. Always assume that people are trying the best, and don't assume people are being malicious when they're irritating you.
It's a good tip for getting along in the world.
Well, in open source projects, we know there's issues with trolls, and usually it's just a matter of sitting down and really understanding what they're doing and trying to make sure the empathy happens. So community building is something that's an art in some ways, and I think we're figuring out some things, and we still have a long way to go in other places. And since we're all remote these days with COVID, we're doing more of the type of community stuff that we usually do online, and more of the wider population is going to start to experience what we tend to do online.
So Zephyr, are these best practices related to community building or to code, or both?
All of the above. So with Zephyr, we looked at what was sort of working with Linux in terms of, processes, things like making it easy for people to contribute. Zephyr works with the DCO, which is a Developer Certificate of Origin. And that's the same that Linux uses, where people sign off on their changes. So they retain the copyrights to their changes. And that means that things don't get unpredictable for them based on who the copyright holder is, or some CLAs that have been signed and things like that. So the Linux kernel has been very effective at using that for 20 plus years. And so that seemed like a good model for us to pick up and work from when we started the project off. We wanted to make sure it was neutral governance so that no one company controlled the entire project. And so when we wrote up the governance docs, we made it clear that, we're keeping the decisions about finance and where we spend the money separate from the technical decisions, which is another lesson we learned from Linux. And we also have, the concept of doing LTSs.
LTSs are what?
They're long-term stable releases.
Oh, okay.
And so the kernel has various long-term stable releases, and generally that's what the distros pick up to put products out on. And it also is where other people take and make products from. And the idea with that is that there's one place that we can focus on making sure that the fixes that are important go. And if people want to sort of do that, they're not constantly chasing a moving target and shifting interfaces. So this gives them a bit of enough of a stability that they can build their products on top of it.
It's the same concept you see with like Ubuntu, right? 1604
Exactly.
LTS and 18.
And 2004 that just came out, for that matter. Yes. Actually, in my background, I was Ubuntu's release manager for a couple of years, about 10 years ago now. And so I learned a lot of lessons from that experience. It was very formative in me understanding what communities are and when they're working well and when they're not, and how to sort of navigate that side of it.
Wow, yeah.
So that's been very formative for me. And how do we make good communities happen, and how do we keep people motivated and make it a good place for them to work in? There's a lot of things that I think that the Ubuntu community did right. So pulling some of those lessons in subtly has been something that we've been working towards. There's a few things that, the Linux community has that we're trying different paths. For instance, we don't have like one dictator at the top of the pyramid. We have maintainers, and we have a TSC chair who sort of fills that role, and that chair is elected every, couple of years. So we have continuity and, maintaining the TSC, but it's, different voices, and it has, the community has a chance to change over. And we've gone through, a change in chairs already on the project. In the same way in our governing boards, we also change, and everything's under election. So it's the peers working with their constituencies to have confidence in them.
What's a TSC?
I'm sorry. It's a technical steering committee. Okay. So it's basically where the maintainers, like with the Linux community, where there's maintainers over pieces of code, and that's where they're sort of meeting. And so when we're adding something that's, new, or, potentially controversial, that's where they sort of can meet to thrash out the differences.
What's controversial? I mean, what kind of things can be controversial with an operating system?
Oh, well, two different people have different proposals on how to do a certain piece of function and the network and things like that. And so it's, discussing the pros and cons and figuring out what's going to be the best future so that the right technical decisions can happen. Or if there's a couple different approaches for doing things on security, that's interesting. One of the areas we're working on right now is what coding guidelines does the Zephyr community want to follow? And that's an area we're sort of trying to all come to agreement on, specifically because we're going to be going after a safety certification as a project. And so we'll have to, comply with certain of the safety standards require this type of thing. And having MISRA compliance is something they're looking for. So figuring out which rules we're going to adhere to and which ones we're going to make a formal exception, and then making sure we have the tooling in place. But, when you start talking about how code is formed, that gets people very passionate. And, we all want to make sure we can get Zephyr to that stage. So we're looking at, okay, how do we get the guidelines that everyone can live with in place? So that's, I think, queuing up for the TSC discussions right now. It's been in the safety committee up till now.
This sounds like a lot of discussions, but this is an actual operating system. It's not just about the organization. Is it an operating system? Is it a kernel? Is it really a real-time operating system? What is Zephyr?
Okay. Zephyr is a real-time operating system, and it has a reasonably complete stack around it now with a lot of peripherals. The same way Linux has a lot of drivers and infrastructure, Zephyr is very similar. In addition to the operating system, there is some infrastructure for building an SDK around it, as well as West, which is a build tool that we've created to support pulling modules in and out of Zephyr for organization purposes. So it is a true operating system. It has been evolving, and there's lots and lots of code going in. I just checked before I got on this, and there's now over 40,000 commits in the Zephyr repo. And given that the project just opened up in, I guess, about 4 years ago, for an embedded project, that's pretty spectacular with that rate of change. So we've been working that up, and there's 672 contributors right now. And when I go and look at insights on GitHub itself, as of today, right now, when I'm looking at it, over 129 authors have pushed 1,300 commits to master and 1,400 commits, or 1,409 commits to all branches. And this is in the last month. So in 30 days. So to put it in perspective, I think we're sort of averaging now over 1 commit per hour. And the Linux kernel community, the Linux kernel itself, the upstream is about 9.4, I think, commits per hour.
So it's active.
So it's active. So we're actually, like I say, we've got a nice velocity, and a lot of the content is there's a lot of really good features going in, and a lot of polishing, and people are finding a good place to do some, to build from, and then they contribute back. And so that's kind of thing makes it really quite exciting to see what's emerging. One of the surprises for me with this project was when, we were aiming for the M core, the MCUs and M cores for the ARM processor, as well as, other architectures in that embedded side. And since we actually started, we've now got a very interesting range of architectures in here, including the R cores, which are sort of a logical one on the ARM side. But then A cores has just started getting added. We started off with RISC-V 32-bit ones, and then put a 64-bit RISC-V port in. Intel, it's been there since the start, and it's been x86 and then x86 64. And we're seeing things like Open Power coming in, which, I would not have expected that to come into a 64-bit PowerPC, to come into an embedded OS like this.
What's the reason to scale way up to the desktop class chips? Is it, I guess I haven't looked into Zephyr's architecture that deeply, but is it a full process model that can take advantage of an MMU, or is it more like your traditional ThreadX and stuff like that?
No, it's a full processor model.
Oh, okay.
You can take advantage of the MMUs, and I think they're putting the some of the more desktop type of cores in, because they want to use sort of in mixed systems,
right?
Where they're using Zephyr to do a limited function, but they're running on the same cores as other, and using other interfaces. Linux may be on other cores, and certain functions get partitioned between different cores.
Okay.
So we're talking about a multi-core system and running Zephyr on some of them.
Yeah.
Okay. So one of the chips that's listed is the Cortex M0, which doesn't have an MMU. How does Zephyr... It seems like that's a dividing line. Like either you run apps and you have a protected memory space for the apps, or you don't really run apps. You run a kernel and a scheduler, and you have tasks and processes, but they're not independent. How do you handle that?
So what Zephyr has is it's using the same kconfig infrastructure that's in the kernel, and it uses device tree. And so you're configuring the parts you want to have working, and that's what lets you actually, statically build it for a certain footprint. Zephyr gets as small as about 8K. Okay, but once you start putting some of the communication stacks on, you're obviously moving towards 512. Okay, but we can do a lot of things in a very small footprint, and we do that by statically compiling what we need. But you'll see that a lot of the work and a lot of the architectures and everything else is selectable, and that's what lets you have that flexibility.
The flexibility is great, and you talked about the velocity and people committing. As an embedded software engineer, I hate it when things change.
Well, that's why we have an LTS for you.
Okay.
So you can basically say, okay, none of my APIs are going to change. It's going to be stable for the next 2 years. I can innovate on top of that, and then I can decide if I want to move to the next LTS.
And when I see Zephyr is supported on a chip on the Zephyr page, what does that mean?
Well, it means that the code is in the repo, and that there is a certain amount of testing that's been done, that it's building and so forth. Some of them are different stages of completeness. And I think it's a matter of figuring out which one you want to use and how close it is to your target. There's certain ones that are very well tested and, very well exercised. And there are others that people are adding. So I think it's a matter of looking and sort of seeing what you want to be using and what you have access to.
How do I look? I mean, what am I looking at? Am I just looking at Git commits in this area, or is there something that will tell me, oh, this chip is fully supported with all of its interfaces, and this chip, well, you can run Zephyr on it, but don't expect a SPI driver.
And we'd love to be that way. The documentation is really pretty good. There's a lot of information we pull out of the documentation, out of the code for the documentation. And then if you look at the docs.zephyr, it goes into more detail about the level of support on certain of the chips. I'd love to have a master big table of, which chips, which drivers, how well tested and everything else. But it's an open source project, so no one's started generating that yet.
Is that, documentation on a normal project is always one of the hardest bits. Mm-hmm. How do you convince people who aren't necessarily doing this as part of a professional role that the code alone doesn't actually stand alone?
Well, this is, I think, where we're sort of lucky in that the companies that are working on Zephyr have had a strong belief in important documentation. In the early part of Zephyr, we've had David Kinder from Intel, who's done an absolutely excellent job of keeping the documentation up to date, and has made Zephyr's documentation look really good. Unfortunately, he's moved on to another job inside Intel, but he's put us on a really good sound foundation. And so I'd encourage you actually to look at our documentation. And if people like to work in documentation, obviously help is always welcome. If you see an error, just open a bug. Mm-hmm. Or even better yet, a pull request. Because all our documentation's up on GitHub too.
It is, and it's pretty easy to read, and it's not just Doxygen outputs. Right.
Yeah, no, like I say, kudos for that are to David Kinder. Like I say, he did a beautiful job.
Your list of supported boards is really long. You already mentioned Cortex M0s, the Cortex A53s, RISC-V.
I didn't see Tech Alpha on there, though.
No Tech Alpha. No one's given us a simulated version of it yet. However, there's like I say, there's a pull request looking for getting Spark in there now.
Oh, God.
Yeah. It's like I say, we're seeing a lot of people, especially with the FPGAs and working with the open architectures. There's a lot of revitalization happening on some of these coding family, like some of the architecture families. So
8051 will live forever.
Oh, no. I haven't seen that one yet. And we do need to have at least 32 bits. Thank you, please. Or 32 and 64. Oh, gosh. Yeah. That was 16, wasn't it? If my memory's correct?
No.
No, it was a 32? Okay, fine.
No, it wasn't.
8051?
Yeah.
It's 8.
It's an 8-bit.
Okay. Thanks.
What do the boards have in common? Do they all have USB JTAG flash tools, or?
I think they all have basically some sort of serial connection that's coming out. Most of them have some degree of some sort of interface coming out, at least one way or the other. And yes, having the JTAGs and the connections, but I don't know that all of them do. I'm not sure if there is really common denominators amongst them all, other than they're all using the same kernel. I couldn't make a statement about the peripherals, not without a lot of work.
Okay. How do I decide which operating system to use? I mean, there's free RTOS that's out there, and there's Zephyr, and there are many, many, many others. You work for the Linux Foundation. You work on Zephyr, so you're going to tell me Zephyr, but...
Well, I also work on Linux, too. I also work with Linux, and I also work with other things. But yes, of course, I've got my biases.
How do you think people should go about trying to choose?
The way they should go about trying to choose is look what their end goals are. What are you trying to accomplish? Are you trying to sell a product? Are you trying to do something as a hobbyist? Would be one aspect. What level of support is there? How seriously, what does it cost you to get security updates, for instance? What does it cost you for moving, getting things that you care about upstream? Can you retain your rights? These are the things that I think are important, that are worth looking at. I also think, is how clear is the licensing? That's important to look at. Could someone come after you for patents after you've put a product out and made some money? One of the choices Zephyr made was to go after the Apache 2 license because it had an explicit patent grant in it. So people who are contributing to it are granting any patents associated with the code that they're contributing. And, these are the sorts of things. So I think it's a question of, what are you trying to do? And what's important to you is this something you're just doing for yourself, or is this something you're trying to scale?
Okay, so let's say it's something I want to scale, that I want to use this professionally.
Okay. So what you want to make sure is that you've got clean licensing, because you do not want someone to be coming after you after you've started shipping. So that's the first thing to look at. Next thing to look at is, the patents. Then it's going to be, how easy is it for me to work with the code base? And can I find developers to work with the code base who have worked with the code base? Then once you start scaling it, are you trying to, and it's out in people's hands, do you have a way of letting them know if there might be a vulnerability in it? One of the things we're doing right now with Zephyr is we actually have a security team that has now been working since the start of the project. So if you look up on the MITRE site, you'll see that Zephyr is actually one of the few open source projects there that is a CNA. And so the project has a PSERT team, or Project Security Incident Response Team, that is responsible for, reviewing any vulnerabilities that come in, and then figuring out with the rest of the team how to address them, and then reporting back to MITRE. So we're working on, we have several that we're working on, and we are being very transparent about them and letting people know when they're fixed. And those who are, and then those who have products that have registered with us, we're letting them know within the embargo period too. So we're taking security very, very seriously, and we want to make sure that it's Zephyr can be used in products safely. And in terms of safety, there's also the whole element of, is your product going to be used in a safety critical context? Zephyr is actively working towards being able to go after safety certifications.
Which ones?
We're hoping 61508 initially. And there's some of our members that will also take that to 26262. We have potential interest from some others in towards the medical device space. And so, but 61508 gives us a good grounding for all of the others.
That's the ISO.
Yep, okay. That's the ISO 61508. And what we're sort of doing is, if we can get to the stage where we can get that certification as a project, I think, and we're keeping the sources available to everyone. So, you'll have a pretty good base. So the next LTS number 2, we're sort of working towards that for next year. And we're hoping to have everything in the stage where we can go after those certifications with that next LTS 2. So it's, like I say, we're working towards it. pretty tightly. We've got a safety team that's working on it, looking at things like the coding standards, as well as, okay, what evidence do we need to do? One of the things that we'll probably be talking about in an upcoming technical steering committee meeting is, how we're going to be mapping code back to requirements, which is what a lot of these safety standards call for.
Yeah.
Bingo. Yep, exactly. And so we've got some ideas on how we can do a lot of that within the code base so that we can generate a lot of the stuff. And as well as, the testing of and so forth. So we're sort of blazing a little bit of a trail here on this stuff by doing it out in the open. And it's kind of exciting. That's actually it's one of the parts of the project I'm super excited about, is that we're making progress here now.
And security and being able to be certified, those are the two reasons to buy an RTOS. Mm-hmm. Because that makes that huge thing somebody else's problem. But one of the things with Linux, and I love Linux, I use it a lot, but it is sometimes free as in a puppy. Okay. Sometimes it is a lot of work to get it working and to get it configured the way I want. And it's super flexible, but it's so flexible that I spend all of my time worrying about my operating system and not enough time worrying about the application, which is what I really wanted to spend all my time on. Mm-hmm. Does Zephyr suffer from that? I don't know how to phrase that question.
In Linux, there are operating system distros, right? That basically do a lot of the configuration, testing, keeping it up to date, pushing fixes at you, Ubuntu, Red Hat, so forth, right? In Zephyr, we are starting to see our ecosystem emerging with solutions there. There's one of our members is Foundries, and they will basically keep Zephyr up to date for you and work with you to make sure it's configured for what you need, and so that you can focus on your application. So there's options emerging, and because it is such a smaller code base than Linux, there's more. You will need to keep on top of it, I guess, is one thing you do need to do, unless you have someone that's there to help you. And there are consultants out there who will do work for you on Linux, as well as they also work in Zephyr. So some of the embedded Linux consultants that are fairly well known in the industry right now, like Consulco is one, Bay Libre is another. I know that they've worked and created Zephyr products for people already, and they also do a lot of work in embedded Linux. And to a large extent with Zephyr, if you're familiar with embedded Linux and the internals of embedded Linux, Zephyr's pretty similar. Using device trees, using the kconfigs, this type of information, and the structure of the directories is very clean. So things are pretty much where you roughly expect them to be. And if you've got suggestions for how things can get better, obviously start pull requests and start the discussion. But there's a lot of knobs to turn and things to adjust. So I guess it depends on the product, right?
It's true of most operating systems. And from the embedded side, Linux has the downside of, not the downside, but it's a different world in that people use it for their desktops or as servers and things, which is kind of a different universe than an embedded device, where once you get your configuration on your embedded device, you're kind of locked down and never touch it again. I was going to ask about architecturally. You said it's similar to Linux. Was it a clean sheet development, or was it let's take Linux and pare it down? Because I remember using Linux in the early 90s, amazingly, and it ran on a 486 with, I think I had 8 megabytes of RAM, and comparable to a nicely configured embedded board these days. It's like, okay, why don't we just take that Linux from the 90s and put it? So was it that kind of thing, or was it a clean sheet with Linux principles?
Actually, it ended up being a sort of clean sheet with Linux principles. Okay. What had happened is that Wind River had made an acquisition of company at one point and had their RTOS sitting on the shelf. They have obviously VxWorks. And when Intel acquired Wind River, they took a look at options, and they decided to start with this RTOS that was sitting inside Wind River called Viper. And the Open Linux team in Intel, the open source team in Intel, basically took that and then structured it into something that was useful from their perspectives. And since it was a Linux team that was doing the initial structuring, you saw a lot of the feel and things that were common in Linux come in.
Okay.
Initially, it was, there was a different make system that was more common to Linux, and they actually switched that out a couple of years ago for CMake because that's what the embedded developers wanted. We initially started on a Garrett system, and we moved over to GitHub because, again, that's what the developers wanted. So the code base is, very much shaped by the developers for the developers. And, the discussions and the, resolution of frictions happens at the technical steering committee level. So Hopefully the best idea works. And they've gone in and done something and then come back a couple of years later and said, no, we should do it differently. And that happens too. So it is an active code base, and it's not like it's written once and it's that way forever. People are looking for ways of improving things, although some parts are now very, very stable and haven't been touched at all, just like in Linux.
So it's probably more familiar to people from a Linux background than somebody who's used to traditional, very old RTOS on the embedded space.
We're getting some of some of our members have coming in from the very deep embedded space, and they're looking at trying to keep up with all the new technologies, like the Bluetooth stack and so forth, and wanting to use that to take advantage. And working with their traditional code bases, it's very, very painful. And so they start looking at Zephyr and see that it's an easy transition to just add the bits that they want, because a lot of the other stuff is there now at a level of quality they're comfortable worth working on.
I'm glad you brought up BLE, because I have a BLE project that's starting, and it's on a TI board, and I'm relatively familiar with the TI operating system with BLE, but not super familiar. Should I ask my clients to pay me to evaluate Zephyr for use on the TI board? I mean, I see that it's supported, but...
Texas Instruments was one of our members for the project. And so, they're demonstrating their commitment to be there with Zephyr by, helping us with membership. And so I'd say that, I think the question is, what's the long-term cost going to be to their client for the product they're going to use? And
well, it's free either way. So the long-term is more about the features they get and the confidence they get from good software.
Oh, you mean the operating system's free either way?
The operating system. Sorry, client. The software isn't free. I'm definitely charging you.
So the question here is, what's the ongoing support cost going to be? Are they likely to deal with vulnerabilities down the road? Is it completely closed, or are their interfaces open? Given it's BLE, there's potential for malicious actors to interact with it potential in some ways. So if they're both free, that's fine. Do you have the support? I guess would be the question. Well, as you said, free as in puppy. What are the long-term costs? And if the long-term costs, if you see support paths and everything else in both options, then they're good there. But if you don't see a support path, then maybe it's worth taking a look at Zephyr and seeing, whether it's close enough.
That's actually the problem, is that with TI, using the TI operating system, that's a pretty clear support path. I mean, they're probably not going to abandon it. Their forums are not necessarily the most active in the way that I want, but they exist. And as long as I'm not coloring outside the lines, what they have will work for me. I know that because that's what they say the chip does. Mm-hmm. But I'm curious about Zephyr and I want to try it, but I'm having trouble. I have all these questions like, is it certified the way it needs to be certified for TI? Can I get to the lowest power? Do I need the lowest power? Can I do all? But that means I have to spend days and days reading about Zephyr's BLE implementation. And I just want you to talk me into...
There's no free lunch, ELISA.
Yeah, I'm afraid. I'd probably reach out to some of the TI folk that are working on the Zephyr project. And I'd ask them.
That's fair. But your BLE stack is certified, and your Wi-Fi stack is FCC. All of the fun certifications have happened for all these things, right?
So the BLE is the one we've been tracking. The Wi-Fi one, I think basically our members have been taking it through, but we haven't done it as a project. With the Bluetooth, we've done it as a project because we're pretty cutting edge there.
Cool.
Yeah. What's kind of exciting for us in the sense that the Bluetooth SIG tends to use Zephyr as a proving ground before they release specs. And so we keep pretty current to the tip of it all and all the new technologies coming out, which has been really exciting for the project.
Yeah, that is. I mean, I know that the TI operating system doesn't support the BLE5 mesh networking. And so maybe that's what gets me over to check out Zephyr if I can. All right.
That's good. Yeah, on the Slack channel, for instance, we've got a really active Slack channel. It's a free one. And so there's no history. So don't think you can bookmark something. Scrape it, please, if you need it to keep it around. But we've got a lot of pretty friendly community. And you'll find people from TI and other places on those channels, and you can ask them questions directly if there's issues and, on specifics. Like I say, if you sit and monitor the Slack for a bit, in the general channel, you'll see that there's a lot of good discussion that's going on.
And the discussion that I saw was both about developing Zephyr and using it.
Mm-hmm. Yeah. In the general channel, you'll see both. And there's other channels that are sort of more specific to areas. But you will see, use and development happening. There's a user list and a developmental list, and it's just a matter of perspective where people seem to ask questions. But I think the most active is probably the Slack rather than the mail list.
How real-time can a Linux operating system be? How real-time is Zephyr?
You've hit a spot that I don't have a good answer for you. I want it quantified still. There's some work I want to do to get it qualified, to get it specifically precise in a way that I trust. I've seen some estimates done, but I don't believe them. One of the other projects I work on is Realtime Linux, so I'm pretty sensitive to this stuff. Okay?
Yeah.
And as a result, I've seen, people obviously claiming that, Zephyr is going to be able to have certain cycle times and so forth. But when I look at the methodology, I'm not quite believing them. So I can't give you a good answer right now because I don't have the data and I haven't got the data from someone I trust yet. Let's put it that way.
All right.
I like that answer because when evaluating these things in the past, it's always been very difficult because every operating system vendor has their own slightly different methodology. And so the numbers look comparable. Oh, we can do, this context switch plus blah, blah, blah in 50 microseconds or whatever. But it turns out it's just slightly different from the other person's who claims 75 microseconds. And maybe that matters. Maybe it doesn't. And it's
And then I'll ask about, okay, what's the jitter aspects like?
Yes.
What's in the face of noise? And then how long is it likely to be sustained? How long has it been running for without issues?
And I mean, I didn't specify a board or even a family of chips. There was no answer to that question.
Well, like I say, I haven't, I've seen a couple of people starting to tackle that, and it's an area that I would, there's some people I want to be talking to this summer, and I'll see if we can start to get some more details emerging on that in the fall. But right now, there's a lab in Germany, OSADL, or OSADL, sometimes it's referred to, and they have a really good real-time lab. And I've been talking to Karsten there about them doing some runs with Zephyr and with Linux and, doing a characterization. And he seemed interested. And so it's just a matter of, finding the right boards to send them and things like that. So I'm hoping, like I say, by next fall, I should have some better data for you.
So real-time Linux is a thing, and embedded Linux is a thing, and Zephyr is a thing. How do I decide which one I want to look at? They all seem overlapping.
Well, Realtime Linux is a set of patches right now that you apply upon embedded Linux. And most of the work for Realtime, the preempt RT patches are going upstream right now. We're hoping that by 5.8, all of them will be upstream, and that we will have the ability to have Realtime just be a config option in the kernel. And it being used embedded is just a comment on which options are being chosen. For Zephyr, when you're looking at embedded Linux, it really doesn't get smaller than 2 meg. I worked with Nicholas Petra when I was at a prior organization before I went to Linux Foundation, and he was busy trying to get it shrunk down as small as possible. And he had to play some pretty intricate tricks to get it down to about 2 meg. And so a usable functional system with Linux, you really don't want to be lower than 2 meg. Zephyr, like I say, we can do 8K for the bare bones as well. And certainly we can go up to there, but 512K becomes reasonable. So it's a question of what's your memory footprint. And then with Zephyr, you're going to be using less of your computing resources, so you're going to have a much longer battery life potential. And so how long does your battery life need to last? One of Zephyr's members is Odicon, and they are doing their next hearing aid line on Zephyr because of the Bluetooth and because of, I think, the battery life. They actually gave a really good talk last August at Open Source Summit North America, and they were explaining how they were using it, Zephyr, in their products. And so, that people are going to be using it in hearing aids.
Wow. Okay.
So, you want your battery life there, right? You don't want to be having to plug this stuff in. And so they find Zephyr to be a good solution there. So, these wearables, things that have to last a long time. One of the other applications I know that's using Zephyr right now is ear tags on reindeers. Yeah. So they're running Nordic Chips. And they've basically put created these ear tags for the reindeers up in Scandinavia so that the herders can track the herd. And the reason it's effective for them to do it is because of the way that the system is set up, whereas if a natural predator takes down a reindeer, the herder is reimbursed by the government for it. And so by tracking the deers and the cost of these tags, effectively they can, recoup more of the insurance money that the government would pay them if predators, prey on it, and they can show the evidence. So that helps a much more natural situation evolve. And, from my perspective, I look at it and I'm really impressed because, you see these endangered animals with these huge collars on and things like that. And I'd much rather them be wearing ear tags so people could keep, an eye on them.
Wait a minute. So hearing aids, ear tags, I'm sensing a theme here.
I was off writing a reindeer fraud screenplay.
No, there's some really cool things emerging with Zephyr. Like the creativity that's kicking into this community is awesome. Just last night, I was reading up about one of the other products I know about that's using Zephyr is InSelenium has these safety shoes. And with these safety shoes, what they're doing is, letting people tap Morse and get haptic feedback in noisy environments. And so they've been, wearing awards. And recently, they just came out and announced this blog post out.
I'm sorry. Mm-hmm. Safety shoes and Morse code. I'm not getting it.
So if you're in a very noisy environment, okay, you can't hear an alarm because of you're wearing headphones and there's a lot of heavy machinery around you.
So your shoe is going to tap on you, not you tapping on the shoe.
The shoe's going to give you a buzz.
Okay.
So there'll be some sort of haptic feedback. And if you needed to communicate back, you can tap, i.e. an acknowledgement or something like that.
Got it.
Okay. Thank you. Sorry, I just couldn't picture.
And so on Wednesday, April 22nd, the InSelenium folk basically announced they're creating a smart sort of tag that goes on to these shoes. It's a smart PPE feature so that it helps with the social distancing and helps support them with social distancing. so that it's detecting, are you close enough to another worker or not? So it's using that type of feature to basically tell you if you're getting too close to someone from the social distancing perspective.
That makes sense.
So you're seeing some really creative ways that people are using the technology to help, help keep other people safe. And one of our other members right now is Adafruit, and they're pivoted in a slightly different direction, but they're busy making face shields in New York City and trying to help things out there. So they're doing awesome work as well. So we're super proud of that member and what they're trying to do to help. So with and without the Zephyr running, there's a lot of creativity in the community, and that's kind of exciting to see where it goes. As with any embedded project, you don't know if people are using it or not. And so finding these little breadcrumbs of where people are using it sort of helps motivate, keep you going sometimes.
That is so true.
Yeah.
Your title is Senior Director of Strategic Programs at the Linux Foundation. That's a cool title. What does it mean?
Well, it means there are certain projects and programs that we're working on here at the Linux Foundation that we consider sort of strategic to the overall industry, and how we can make things better. And so I have a portfolio of projects that I help. And so it's different roles in different projects, from the director of the project to, someone to help facilitate communications. It's, there's a lot of different things I work with, but, I work with Realtime Linux and I work with Zephyr. And then the other project I'm working with right now that's kind of exciting is something called ELISA, which is enabling Linux and safety critical applications. And again, the safety theme's kicking in here, but because of standards like 61508, they were written with a very specific mindset and a specific model of development in mind. And what we're trying to do is figure out what is it going to take to make people feel confident that Linux is safe, and what sorts of what should they be looking at in their analysis before they deploy a product that could have a safety critical application. Things, our Teslas out there right now are running Linux. I don't believe they've gone through 61508 certifications. How can we make sure that these, as we get towards the autonomous driving, they need the processing power of something like Linux. How can we make sure these sorts of things are safe? How can we figure out what's important there and in other applications? And what level of safety? So it's a big open question, and we've gained people from all different spaces coming together to try to help figure this out. We've got a medical devices work group right now where we're looking at where Linux is being used in medical devices, and we're trying to figure out how can we analyze the interfaces around it. And we were looking at there's an open source project called OpenAPS, which is Open Artificial Pancreas System. That's a project that's being done by type 1 diabetes for themselves. It's a hobbyist project, but what they've done is improve the quality of their life by creating a closed loop between their insulin pump and glucose monitors and stopping the alarm fatigue. And so we're sort of looking at how Linux is being used there. It's not a key component. It's not the algorithm, but the algorithm is running on Linux. And so, what's really important, and trying to do some analysis there. Recently, though, we decided to apply our analysis work onto the open source ventilator options that are out there. And so we've been looking at the various open source ventilators there and starting to look at trying to do some safety analysis with some of them. And, there's one I think we're going to standardize on. Like I say, we're finishing our surveys off right now that has a good part of it there, and it looks like it's in reasonable shape, but there's going to be communication happening to a screen somewhere for displaying the results. And that's where Linux will end up fitting in, we think. And so we're actively monitoring what's going on. And that group has got people from UL, Underwriters Laboratory, as well as some of the TÜVs over in Europe, participating in trying to figure out how can we figure out whether Linux is safe or not in these sorts of situations, and how can we mitigate the risks, which is mostly what safety analysis is understanding your system and then mitigating risk. So we're sort of going after it from that perspective in that group. There's another group, obviously, for automotive, and we're looking at trying to form one working in the robotics and industrial too. So there's these different, use case domains working, and then we're looking at, okay, how do you break down the process and relate it to like Linux and relate it to the standards processes? What's the evidence that's there, what's not there, as well as, how do you start looking at key parts of Linux that are important? And, there's one researcher who's, doing formal verification on parts of the scheduling part of the kernel, for instance. And, are there other places we should be doing formal verification? Things like that to make Linux safe. So, on one hand, you have something like Zephyr, which is very small, and you can go through the traditional processes. And then on the other hand, you have Linux, which has a whole slew of interesting domains to interact from, and some hard and some hard problems to solve. On the other hand, it's, everyone seems to agree that it's got pretty good quality at this point. And so, there's a lot of things that are in place to keep it with good quality. And so it's just making those visible in a way that the safety people understand.
That's a tough thing to do, both from the safety, getting people to understand, but also it's a lot of work to get anything safety certified. I mean, really an amazing amount of work. Yeah.
But, if people's lives are going to be depending on it and there's, liability issues, you really don't want anything to go wrong. And so figuring out how we can make it easier for people to do these types of tasks is one of the things we're sort of looking at in this group, as well as, trying to do as much of the work for everyone as we can in Zephyr. So there's going to be more and more of these types of safety critical applications happening. If I ever needed an implant, I'd want to be able to know I could, that there's an open source view of the code somewhere, and I can understand what's going on sometimes. These are, and want battery to last a long time too. So these are all sort of places that we want to see, safety brought into and be accessible to the applications, because there's a lot of cool ideas out there, but we want to make sure that they can be used in a safe way.
And the neat thing about Zephyr is not only are you building the thing and certifying the thing, the Zephyr part of it, you are showing everybody else how to do it, which is definitely important too.
We're showing people how we're doing it for Zephyr, which has a certain, set of parameters around it. And we're sort of working our way from a very small subset of the functionality in Zephyr up. On the Linux side, we're basically looking at different techniques to accomplish the same types of goals. And it's a really interesting spectrum between them. The other project I look at is Zen. I sit in on their safety team there. And I'm trying to make sure we cross-pollinate between all three projects. What are the best practices to use? And so in this way, these things are all strategic, and that's why I'm getting involved in them. Another area that's strategic is, how do we make sure that we can have transparency in the supply chain? So do you know what's running on your device? A lot of, do you know what's, we saw things several years ago about Heartbleed, and, that's sort of on the service base. But when you start looking in the embedded side, how do you know what's on your device? Well, unless someone gives you an accurate software bill of materials, you don't. And, if you're running a BLE stack, someone could potentially hack it. If you don't know if your version has been updated, what stack's on it, you may or may not be susceptible. So we need to really improve the transparency of what we're sharing for software information, so that we can, use these things safely.
Embedded systems are going to have to grow up soon.
There'll always be a place for people to be creative. Come on.
Oh, yes. Oh, definitely. It's just thinking about all of the additional stuff. It's important.
Along those lines, if I got excited and wanted to try Zephyr out, what's the quickest route? Is there a specific board that's great? Or is there a tutorial that says, hey, go through these steps and you'll be up and running in hours, days? There's
a bunch of quick start guides for various boards out there to get to Blinky effectively.
Cool.
One of the boards that we really like and is well supported is Phytic. Actually created a board for the project.
Oh, great.
So you can, that one. And they've actually had extension boards on it and things like that. So adding different peripherals. But that one's very well supported. And it's got a little LED on it. And it also has basically the Bluetooth. And so you can sort of signal to each other in a set of them, things like that. So depending what functionalities you want to play with, the Phytic board is a really cool one. And there's other ones that are out there from some of our other members like NXP and Nordic and so forth that are like the Nordic thingies are all running Zephyr quite well, as is some of the NXP ones.
Okay.
So there's some good options that are available pretty cheap too.
And if you look at the list, there's a good chance that most of the people listening to the show might have one of these boards.
Yep, I would say so.
I mean, the discos are all there, okay. And the explains and the nucleuses and there's this list is very long. ESP32s, that might be fun.
Yeah. There you go. No, it like I say, a lot of people have contributed a lot of boards, and this is how we've got so many commits, right? As people are putting in what they're needing and using on a day-to-day so that it's kept up to date with everything else with our testing infrastructure.
I mean, if you're going to have to write a SPI driver, you might as well write a SPI driver other people can use.
Exactly. That's the whole benefit of open source.
Kate, thank you so much for speaking with us. Do you have any thoughts you'd like to leave us with?
Sure. Just, in this crazy world we're in right now, stay safe and be creative with the extra time you've got at home now.
Our guest has been Kate Stewart, Senior Director of Strategic Programs at the Linux Foundation.
Thank you, Kate.
Thank you.
Thank you to Christopher for producing and co-hosting, and thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on embedded.fm. And now some thoughts to leave you with. Zephyr, as you may know, is the name of the west wind, the bringer of spring and summer breezes. But did you know that Boreas is the north wind, bringer of cold? Notice is the south wind, the hot wind, and Eurus is the east, bringer of rain. Happy spring, Northern Hemisphere. Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.